If you do a search on the internet for the Lorentz transformation, you will find numerous websites that derive the transformation, sometimes using multiple pages. Some will describe the transformation as relating one set of spacetime coordinates to another. Unless you are very adept at mathematics, it can be very intimidating. There is a very simple way to illustrate just what these spacetime transformations are actually doing. If you want to see what the relationship between two inertial reference frames is, just lean a meter stick against a wall. The meter stick that is leaning we'll call the x inertial reference frame, and we'll consider this one to be at rest. The vertical meter stick is the moving reference frame that we will call x prime, and the one on the floor is simply the velocity as a decimal of c. Say you want to know the relationship of the two reference frames if x prime is moving at half the speed of light relative to x. Simply place the base of the x meter stick at the 50 centimeter mark to represent 0.5 c. Lean the x meter stick against the x prime meter stick, and there you have it. The top of the x meter stick will reside at 86.6 centimeters. Moving at half the speed of light, a meter stick will be 0.866 meters long, or 86.6 centimeters. A clock riding along with that reference frame will run at 0.866 times the speed of the stationary clock. You can do this exercise with a stick with no markings whatsoever. Place a stick against a wall that is 90 degrees to the floor. Using a protractor, measure the angle between the leaning stick and the vertical wall. The cosine of that angle is the Lorentz contraction. Take the sine of the same angle, and that yields the velocity.